Well, good evening, everyone. Thanks for joining tonight's TI Technology webinar hosted by Texas Instruments, where I'm excited that we're going to do something a little bit different tonight. We've done a bunch of SAT-focused webinars where we talk a lot about the SAT and strategies. Tonight, we're going to really focus on the technology that you can use to help your students succeed on the SAT. And one of my favorite things about it is they're going to be learning really good math along with it as well, and not just focused just on the SAT. So you're getting some bonus stuff tonight. My name is Mike Houston. I'm the moderator for this event. I teach algebra and calculus near Pittsburgh, where I use TI technology to make tough to teach, tough to learn concepts accessible to my students. And tonight I'm joined by Patrick Flynn and Scott Knapp. Pat's been teaching math for over 30 years. He's currently teaching AP Calc BC in Kansas, and he is a 2013 Presidential Award winner for excellence in mathematics and science teaching. He served on TI-Nspire authoring teams, as well as a writer for the We All Use Math Every Day program in conjunction with the television show Numbers. Pat has presented at many international, national, and regional conferences in the areas of technology, calculus, algebra, and geometry. So, Pat, it's great to have you with us tonight.
Thanks, Mike. Looking forward to a great evening.
And Scott's in his 25th year of teaching high school math, currently teaches pre-calculus and AP Calculus AB at Glenbrook North High School in Illinois. He's committed to supporting math educators. Scott has been a Texas Instruments TCUBE regional instructor since 2011 and has also served as an AP Calculus reader. Scott's co-authored professional development resources for both the TI-Nspire and TI-84 handhelds, and has presented at conferences as well, and led workshops across the country, sharing strategies to enrich teaching and learning through the use of technology. So, Scott, it's great to have you with us as well.
Thanks, Mike, and welcome, everyone.
So tonight, I just want to remind everyone that we're going to be using the chat window a lot. Send general messages. If you have any questions, feel free to ask that in the chat window. I know Scott and Pat will do their best to get those questions answered live. We are going to be going through a lot of stuff tonight, so I don't want to hold them up. Just know that you'll get a link at the end of the webinar to the certificate of attendance, as well as a link for the documents. So that's going to be really important to stick around to the end. So without further ado, guys, go ahead and share your screen.
Well, Scott and I are really excited about tonight. We're going to be using the TI-84 and the TI-Nspire, right? So we're going to be showing both platforms here. Specifically, the things that we are going to be focusing on are finding minimums and maximums, evaluating functions, numeric solving. Yes, we'll use your handheld to solve equations, solving systems of equations, using sliders, graphing a circle, graphing inequalities, and hopefully graphing equivalent expressions. These are big things in the SAT, right, Scott? I mean, and you in Illinois, it used to be an SAT school, I think, too. So you're really well-versed in this SAT world.
Yeah, we recently switched over to the ACTs, our state test, but we had been SAT for quite a long time. And so we've got a lot of skills to cover tonight. We've got an aggressive schedule. We're going to try to get to as much as possible, but we chose these based on combing through SAT tests and practice tests and looking at the actual problems that students are facing and how we can leverage the technology as a strategy to help solve the problems and get a better score eventually on the SAT test.
Right. And so go ahead, Scott.
No, it's okay. I was just ready to go if you're ready to go.
I'm ready. So each one that we're going to do, we're going to have an actual SAT question that's been released. We'll be using both platforms, the 84 and the Nspire, to solve these questions. And then as an added bonus for like after our workshop is done, after this session's done, we will have questions that are in the PowerPoint that you'll be able to do at home practicing the skills we're going to do tonight. So that's pretty neat.
Yeah, and we'll show you what that looks like here as we get to that. But let's go ahead and start with our first feature, and we're going to look at a problem on the SAT where students are asked to find in this case, minimum, but a maximum or a minimum. So this is a quadratic equation. One thing to notice about this problem is it's not multiple choice. It is one of those open response where you would have to, now that the test is digital, type in the answer, much better than bubbling it in, if you remember the old format of the test. But I'm going to pull up my TI-84, and we are going to solve this problem using the 84. So I'm going to first enter this into y equals the quadratic function here. So 4x squared, and then minus 50x, and then plus 126. And Pat, you shared a tip with me that you tell your students about what to do next before I actually press graph.
Yeah, our students tend to do a lot of zooming around on their calculators, especially if they have like AP stats with lots of these weird settings. So I always tell them, no matter what we do, you always want to press the zoom button and choose standard. That's going to force the handheld to go from -10 to +10 in both directions. It might not be the best window, but it'll get us a good start as to what's going on. Because a lot of times kids will be like, sir, my calculator doesn't show it right. I'm like, zoom standard. Oh, okay. Got
Yeah,
it.
it's a good baseline to start at, right? Because most things,
Right.
at least you're centered at the origin, which is where we're typically thinking graphically, and we don't know what was graphed previously. So it's a good idea to press zoom and then zoom standard. And so here we've got our quadratic function. I always tell students, think about what you're expecting to see on your screen when you press enter or zoom standard. It does look quadratic. It looks like a parabola. But we're not going to be able to answer this problem with the current window, so we've got to do a little bit of work changing the window settings. And which of the settings am I going to have to change here, Pat?
It looks
I'm
like
going to
we
leave
need
the
to
screen.
looks like we need to make the calculator look a little bit lower, right? So with that Y minimum, we need to make it a heck of a lot smaller than -10. So I'm going to guess and take a shot in the dark and go -40. Let's see what -40 does to us.
Okay, so I changed that to -40, left everything the same. Probably wouldn't change the scaling if I was on an SAT test and worried about that. I just want to make sure I can see that the vertex of the parabola. So I'm going to go ahead and press graph, and we do see
There we
the
go.
vertex on the screen now, which means we can calculate the vertex on the screen. So I'm going to grab my calculation tool. I'm going to press second and then trace. That will give me my list of calculation tools I have available. And make sure you choose the right one. I've accidentally touched the wrong one and it can't find something that isn't there. So make sure that we're looking for the minimum here. So I'm going to select minimum. And you've got a couple of options here. We can either arrow over. Now notice that parabola, as far as what's on our screen, isn't until x is at least 3, well, around 3. So we're just about to see, there we go, the first time. But another option, if you want to be a little bit quicker, is you can actually type in a left bound and right bound. And since we know we started on the standard window, perhaps if I typed 0 and notice that appeared at the bottom of the screen, x equals 0. And when I press enter here, you see that there's this little triangle showing that it's looking to the right of that. And then I'm going to press 10 as my right bound and press enter. And it wants a guess. And the reason for the guess is, what if there's more than one minimum? There's only one here, so I would probably just press enter, but I tend to just arrow one little space towards it just to be safe, and it will lock in. And so what does it look like we have as an answer here, Pat? Well, we gotta be careful, right? Rule number 1, when you're taking a standardized test, read the question. What are we looking for here?
Right. It says what value of X, right? So don't be that student and give the Y value. The question says what value of X. And we also got to be a little smart in this answer, right? 6.24999. I believe that's 6.25.
Yeah, I think that the way that the calculator is built is it's finding that approximation, but I do believe, yeah, you're right, it's 6.25. And it's important here because it is one of those where we have to type in the answer. But be very careful, because if this were multiple choice, they may ask for what is the minimum value, and those distractors would be there. So we've got to be careful here so that we use the technology to get the right answer, which is the 6.25.
Right. Now,
Okay.
how do we do this on the Inspire, Scott? It pretty much a similar method.
Yeah, I think the two platforms do this very similarly. So let's show that and what that looks like on the Inspire. So we're going to graph the quadratic function on the Inspire, and then we're going to grab the tool, the minimum tool, just like we did on the 84 in the Analyze Graph part of the menu. So let me pull, oops, I went a little too fast there, but let me pull up my Nspire. And let's see, I always have my students, an
Right.
important time to kind of to say this is, the Inspire has different page types, but on a standardized test, and I even tell my students on the AP test, I think it's probably a good idea to just use the scratch pad. And the scratch pad button here is just 2 buttons above control or 1 below escape. And what it has is it has a calculator and graphing page already set up, and they can communicate with each other. We'll see that at some time. And you can toggle between the two if you just keep hitting the scratch pad key. So I always tell students that's probably a good thing so you don't have to mess around with opening up new document types or page types as you work, and just stay in that space for the standardized test. So now that I'm on the graphing side, I'm going to type in the function again. 4x squared. Pat, make sure I'm typing it in right.
You sure are. The biggest
Okay.
mistake is like just typing in something wrong. You know, it happens to the best of us.
And that's why I always tell students, think before you press. Now we don't have a lot of time to think on the SAT, but we want to see a parabola, right? Or some semblance of one, because you can catch your mistake real quick there. Now, there is a fundamental difference here, I think, as far as changing the window goes. And I like the Inspire for how this works. Remember on the 84, we had to leave the screen to go change the window. You can actually change the window live on the screen. And so I can do that by double clicking on the value I want to change. So I double clicked on that Y min, and I'm going to type in, Pat, you said what, negative 40?
Right.
Okay, we know we're going to see it there. And I'm going to press enter.
Nice.
And again, we now see, what we need to see on the screen in order to find that minimum. So I'm going to go to menu. Always the menu takes you where you need to go. I want to analyze the graph. And that now looks like that same list of tools that we had on the 84. That's where you find them on the Inspire. And I'm going to grab the correct tool here, minimum. And a little bit of a difference here is I don't have to, kind of arrow through the function. It gives me this vertical line where I can do a left bound and a right bound. So that's kind of nice. And notice it's finding the minimum in that shaded area right now.
Yeah.
So if I want to find the minimum, I got to go past where the minimum occurs, and we get it to drop in that way. The tool also works the same way as the 84 did, where we can type in bounds. So if I know it's between 0 and 10, I can type those in and it will find the minimum the same way, and it's the same value.
It was so
Okay.
nice, Scott, when you were dragging that region over, just watching it visually displaying the minimum as you go. What a great teaching moment in class to really talk about what's going on.
That's right. Yeah, I think it is great. I just saw a question. How do you get that scratch pad window? Super, super easy. So when you're in a document space, you can always, I don't have a new document here, but let's say I had a geometry page set up. You can always kind of exit the document space at any time by pressing the scratch pad key. It's that key right here. It's right now in red. And so if I keep toggling between the two there, I get the graphing side and the calculator side. And we just had a question also about the digits.
Right.
Let's see, what are my settings tonight? I'm on float 3, probably not the best, right?
Right.
My guess is I usually use the cast side, so I haven't used the non-cast in a while. I'm probably just going to go with auto maybe there. If I were on an AP test, I would maybe fix 3, but let's see what happens.
Another neat thing, Scott, I remember is I always like to hover over one I wanted to see more of and just pressing that plus button, like, hey, show me more digits if they're available.
I don't know if I can do that here on the smart view, but on your handheld you can if you hover over. I think we actually have exact values here. The 6.25 and the negative 30.25 happen to be exact, which is why we're only seeing the 2 places.
Perfect.
Okay. All right. So that's finding a max or min. What do we have next? Oh, well,
I think our next one is we're going to be evaluating functions, and we're going to look at an exponential function here, but SAT has all kinds of functions. Oh, but before that though, right? We talked about this.
So we said earlier that after each skill, we also have an extra problem built in there. And just to show you what that looks like, I'll go through these quicker next time. It is a new problem, and we've created the screenshots just to, if you need a little bit of a help of seeing, okay, what I don't remember what I was supposed to type in or what the windows looked like. We did that for both the 84 and for the Inspire, so you can see exactly kind of what you would look at on your screen.
Right.
Okay,
It's
so those
in that
are there in the
learning
PowerPoint.
at home. This would be a great way for y'all to practice these skills, that spacing effect, right? Come back, look at this tomorrow, try these other questions. But I think
Okay.
our next topic we're doing is evaluating functions, and we picked an exponential function to look at, but there's a whole bunch of functions that SAT really likes you to go through. And I think on this one, on the 84, we're gonna type it into that y equals screen. Yeah, right.
And then we're going to use the calculator to calculate because they can communicate with each other. So
Right.
I'll pop back up my 84 and I'll go into y equals and I'll clear out that quadratic function we had and I'll type in the exponential function.
So the thing to remember is we're typing this into y1, right? If we're typing it into y3, we'd have to remember y3.
Yeah, so I always tell students type it into the first one you've got available because it's easy to remember then, right? Y1. And now I'm going to leave the entry screen and I'm going to come over to the calculator screen and I want to type in, I can't type in f of 0, but y1 of 0. So Pat, can you take me through how you have your students access?
There's a lot of ways to do this. Like teachers have been teaching for, remember all those crazy menus, but it's alpha and then one of the buttons on the top. And a lot of students kind of have a hard time remembering, gosh, which button on the top is it? So I usually tell everyone, just press alpha y equals, and that'll bring it up. And then Scott, you had pointed out, like, we can actually see the names here, right? Frac, function, matrix, y variable. We can use the arrow keys to kind of move over from one to the other to the other. I mean, it's way more efficient just to remember it's alpha trace, right?
Right,
But
yeah.
if you're kidding, can't remember that, just alpha y equals, and then just use the arrows to get to the right sub menu that you want. And these things are things that people access a lot, right? So that's why they're put into this special menu.
Yeah, and it's made it very nice and streamlined and really easy to find if you can't remember, although you tend to remember if you've done it a lot. So I'll grab the y1 and I want to evaluate that at 0. And so now the calculator is going to do all the work. It's going to put the 0 into y1 and tell me the value I get out, which is the 270.
It's nice. It's just like function notation. It really looks nice for the students.
Yeah, and just to point out, what if we wanted to just for the sake of, what if, I don't know that we don't have a composition problem, but it can actually do, work with that. If I did y1 of y2 of -3,
yeah,
it can actually do that as well. So that's pretty powerful and nice just to know, keep that in your back pocket because you might want to use that at some point too.
Yeah, makes it quick. Now, I think you really like the Inspire version of this because it definitely has some advantages, right?
Well, my students use the Inspire, so I'm more familiar with the Inspire. But I think one thing that I like about the Inspire is we can actually define the function outside of the graphing window. One thing I always tell my students when you're working on that scratch pad, whether it's on an AP test or for a standardized test like the SAT, I always tell students always clear out to start over. So if we hit dock and arrow up, we can clear that scratch pad out. Okay, and now that graphing screen and the calculator screen are cleared of anything that was entered in them. You can do the same way that we just did on the 84 on the Inspire. You could enter this into f1 of x and come to the calculator screen and type f1 of 0. But one thing I like about the Inspire is I can actually define the function on the calculator side and then evaluate with it on the calculator side. And then I only have to stay on the calculator side. So if I press menu and actions, the first action is define. And so I'm going to press enter and I'm going to type the function as is. F of x equals 270 times 1/10 to the x power. And as soon as I press enter, that function is defined. And now I can press exactly what the question asks me to do. I can find f of 0. I don't have to call it y1 of 0 or f1 of 0, and it will do that same work. And I like it because just one-stop shopping here. I only have to go to one screen, And I think that's always a powerful and more efficient way to do things as well.
Well, and so great with that composition you mentioned earlier, where we're not, like you said, we're not going to mix up y1 and y2. We're actually using the names of the function. It prevents one of those hurdles that some students have. That is a great idea.
Yeah, and just showing you that it can do compositions. Oh, interesting that ended up being the same number, 270. Wow. Bonus. Well,
All right,
we don't have time to think about why that happened,
we
but
got to move along, Scott. We got to move
we
along.
got to move along. Okay. And then we've got that extra problem for you. This one turns out to be, let's see, it's a cubic, but same idea for you to practice on your own.
So our
Okay.
next one is really pretty great. I'm excited about this, is numeric solving. The TI-84 and Nspire both have numeric solvers built into them. And as math teachers, I like seeing the kids show the work always, but man, what a great tool when someone gets stuck. I'm like, I don't know how to solve this. No problem. We can just type this equation into the calculator and solve it. No matter what kind of equation it is, rational, I mean, crazy things.
Yeah, and so
84, yeah, 84 is hiding this one, isn't it? It's in a
it is.
weird place.
It is a little bit, but before we dive into that, Pat mentioned the math, right? We're not trying to avoid doing math here at all. In fact, math would be the most efficient way probably to solve all of these problems. But sometimes students can't remember all the math, or they're not confident in the math that they're using. And that's why we would want to, jump into the technology and leverage it. So, just keep in mind that we want our students to be using good math when they can, but now they have a plan B, perhaps, for certain types of problems that they're not confident in. So yeah, let's see if we can dig out that numeric solver, because you're right, it is kind of buried. So let me pull up my TI-84 here. I'm going to clear everything out, because that just makes me a little more comfortable. Let's see. It's not an app.
Right.
I
You'd think
actually
it
have
would
to
be.
go. Yeah, you would think it's in the apps, but it's over here in math. And we don't see it there, but if you arrow up, it's actually hidden at the bottom of that math menu. So you have, you don't want to arrow all the way down. If you arrow up, it goes to the bottom of the list. And I'm going to grab that numeric solver now. Okay. And the screen pops up and looks like this. And what it's wanting us to do is type in expression 1 and expression 2 that are equal to each other. So left side, and I can use any variable, which is a bonus, I think, that we don't have to just use x. So z squared plus 10z, so alpha, and then the green keys here, and then minus 24. Hit enter, go down there, right side is 0, so that's okay. And notice here I'm going to hit the graph button because that's what it wants me to hit to say okay. So sometimes you get stuck and think it's just enter, enter, enter. But if I press graph here, it now sends me to this next screen. And Pat, what is it wanting us to do here?
It wants us to guess. So the calculator needs like a starting place to start its numeric calculation. So it's going to find whatever we type in, it's going to find the numeric solution that's closest to that number. Now the problem comes up, like let's say an answer is like -5 and +2, right? Depending what I type in, it's going to find the closest answer. So to kind of help out my students, I always tell them to one of your guesses, make it a very, very small negative number, like maybe -300, and then maybe do a very large positive number like +300. And that way we're trying to find the closest ones, right? So if we say start at -300 and we click the solve button, which is the graph, right? Oh my gosh, there's one of our answers, -12. But Scott, like I think you had mentioned earlier when we were practicing this, that, well, what if it asks, hey, what's a positive solution? Like we're getting -12. So there's got to be something else. So I think if we did 300, +300 for our guess, we would get the answer closest to this, which I believe this number would round to be a 2. Remember, like I said, there's a numeric algorithm that's going through, and there's a little bit of rounding here involved. This should be the answer of 2.
2, yeah. So this one had 2 different solutions. We've seen a lot of problems in our time on the SAT where they may ask for the positive or the negative. So that guess could be important.
Or even the
so
sum
just
of
keep that in
both
mind.
of them. Right.
Or maybe the sum of both of them. Yeah. So, and ideally we want students to go in thinking, okay, it's quadratic. It's most likely going to have 2 real solutions because most quadratic equations do. So, it helps to kind of know that as background too, but it certainly helps get those solutions quickly if the student
Right.
can't remember
Now,
factor.
I'll say
Go ahead.
one thing before moving on to the Inspire, we do want to point out there are other ways to solve this on the handheld, right? Like we could graph and so on, but we felt like a lot of people just weren't aware of this numeric solving
Yeah,
ability on the handheld. So
yeah,
trying to open
absolutely.
up some eyes.
Yeah, absolutely. And how to use it too. All right, so we're going to do something similar on the Inspire. So let's grab the Inspire and I'm going to clear out just because that makes me feel comfortable again. And on the Inspire on the calculator side, I'm going to press menu. And then you got to think through, what am I doing here? I'm doing some algebra, some algebraic solving. I have an algebraic equation and numerical solve. My students tend to get used to NSolve and they may just actually type it in. So, they can type the letters NSOLVE in
Yeah.
parentheses, but you can also use the menu. So whatever works for your students quickly is great. And again, we can use the variable that they have. So z squared plus 10z.
And I
And
think the thing to remind people while you're typing this in, Scott, is that, we're picking a quadratic here. It could be a crazy rational function that we're having it numerically solve, right? Some bizarre things, and this can handle it really well.
yeah, it can to numerically solve. Now, you may not know necessarily all the time what the exact syntax, how they want us to enter this. So I want to point this out just because it can be helpful. Obviously, you don't want to have to do this during a standardized test, but if you're not sure how to finish off the syntax, there's a button just to the right of 9 here. It looks like a book. It's the catalog button. And I'm going to press that, and here, I'm going to pretend I didn't have it already on NSolve. It starts at the top of the list, in the A's. I mean, you could scroll, but you're going to be scrolling a long time. There's a lot of things this calculator can do. But if you press N, you get to all of the commands that start with the letter N, and it does take still a while, but NSolve. And now we can see here that it wants us to have the equation, which I have currently on my screen, and then I need to put comma the variable to solve for. And then if I want it to, like in the case of multiple solutions, have a guess, I need to type that variable equal to the guess. Okay, so that catalog can be very helpful for times where you're not sure how to enter something or you get an error message. So again, Pat liked the idea of, I think, z equals negative 300. And so I think that'll get us the -1. And now I'm going to, instead of retyping everything, I'm going to go up and highlight that command and press enter. And it's really a cut, copy, paste, and pasted that same entry line down. And now I'm going to go to positive 300 and we can get that positive solution.
Nice. Really
Okay.
clean. Again, it's for that kid that, like, man, I am super stuck. They're panicked. It's a high stakes exam. We've got a way for them to be able to have some accessibility to get this question right now. That's the best part about it.
Yeah, definitely good. Okay. All right. And so there is another equation here for you to try on your own down the road. Next up, we have systems of linear equations, and there are a lot of
Right.
those on the SAT.
Absolutely, there are. And I think the TI-84, and sometimes they ask different things. Like this one's asking, what's the value of Y, right? So like you said earlier, pay attention to what the question's asking, like our minimum question, right? What X value? This wants to know what the Y value is. I've even seen some that'll say, what is the sum of the X and Y values of this solution? So you really want to read carefully on this.
Yeah, exactly. So on the 84, we're going to use an app. We're going to use the simultaneous equation solver.
Right.
So let me pull up my TI-83. Let's get out of there, and I'm going to go into apps, and let's see. Is it on my list here? I think it is. Just
Yep.
down here at the bottom, right? Poly
Yep. Number 9.
simultaneous
Yeah.
2, so number 9. And we don't want to find a root here. We're going to solve simultaneous equations, or the system of equations. So we want number 2. And then we're going to get a menu that looks a little intense here, but the nice thing is it's pretty much set for what we would typically use it for, which is 2 equations and 2 unknowns. And then you have some different settings you can go with. So, assuming most of the systems on the SAT will probably be 2 variable systems, 2 variable linear systems. So I'm going to press graph, which gets me to the next screen. And now I'm just going to type in all of those coefficients. Be careful, make sure, you know, this is set up to enter the coefficients for X first and then Y. I've seen some systems where they switch the variables around a little bit. And so you got to be careful here. We're okay. You can change the symbol to plus or minus. And so I'm going to put a 1 there, 48. I'm just pressing each number in and pressing enter.
Yeah, you got to make sure the format is the right setup for sure on this. But it's nice how as you press enter, it advances to the next tab or next text box to type values in. And then we have a lot of choices here afterwards.
Yeah, and again, you might think these apps are built a little bit differently. Enter here is to enter the values in the little template there. But to actually solve, I've got to use what they want me to press for solve, which is the graph key up there. Okay, so if you get stuck, remember that sometimes it's not enter anymore. It's what keys are up there on your screen. And so when I press graph, oh, very nice that it gave us negative 4/3 in that pretty, you know, fraction way of showing that. And then what is the value of y is the answer, which is 80.
Right. We got to be sure to report that answer, not the fraction. Because like you said, on the computer test, right, that's what the SAT is. They can type in the fraction very easily, all this stuff. I've even seen some kids, sadly, type in the coordinate, like parenthesis, X value, comma, Y value. And it's like, no, just do what it's asking. You've done all the great math.
Yeah, and my guess is that's the purpose of some of those open-ended questions is that, hey, you got to read the question carefully, right? Okay, let's go to the Nspire next.
Right.
And this Nspire also has, you know, it's not an app, but it's just something built into it where it can solve a system of equations, linear or nonlinear. So I'm going to grab my Nspire. I'm going to do a quick clear out. And I'm going to go into menu here. And again, you got to kind of think intuitively here. I'm doing some algebra. So let me go there. We did numerical solve. Now we're going to solve a system of linear equations. And so I'm going to hit that. And it's kind of, again, defaulting to what the students probably are going to need to use on the SAT. 2 equations. Variables are X and Y, which is convenient. And it gives us a nice little template. And we just physically type in the full equations.
Right.
So 24x plus y equals 48. 6x plus y equals 72. And I press enter and I get my solution there.
Beautiful.
Yeah, nice and quick and easy. Okay. Let's see.
All right.
What do we have next, Pat?
Well, we got again some questions for them to do at home, but our big one that we're really excited about is sliders, and I think we really just need to give people a chance just to think about this problem. This is tough. You know, y equals 3 and y equals ax squared plus b. So there's 1, 2, 3, 4 variables, and we're trying
there's
to
a lot
find-
going on here, and you know, this probably would be really confusing to a lot of students. I mean, you have to have a lot of comfort, you know, in transformations and that sort of thing. So this might be a stumper for a lot of students, and they're not sure what else they could maybe do. So we're going to use sliders on both of the platforms and show you how to do that to come up with the right answer. So in the 84, we have to use another app, and that is the Transform app. So let me pull up my 84. And I'm going to quit out here, and I'm going to go into my list of apps. Oh, let me quit out the app I had before. And again, this is one of those, if you arrow up, you'll get there quicker. The last app on that list is Transform, and it gives us this nice screen, and really it gives us some information, but we just want to press any key. And the way that you know this app is activated is if we press y equals now, notice it looks a little bit different to the left here. Let me come down to y3. You see that it's, you know, y3 on down has just like, I'm going to graph, you know, in a thicker, you know, thicker text, you know, there. But on the left here of y1 and y2, it has kind of like this pause play button. That's what the Transform app, it's now activated in those 2 entries. So I'm going to type in y1 the first equation, y3, but in y2 it's where the app's really going to come alive, because it knows that if I put in an a, that's going to be a parameter that it's going to attach to a slider. So a times x squared, and then plus, we've got b. Now, Pat, is there any rule about how many different parameters are available?
I think you can go up to 3.
Okay.
And also before we graph, I want to remind us, remember we changed the viewing window from earlier, right? We jumped down to -40 a while ago. So again, we still want to go to that zoom standard to get it back to like that normal viewing window.
Yeah, for sure. So I'm going to press zoom standard.
There
And
they
right
are.
now, we see the line y equals 3, the horizontal line. We see the quadratic function. And right now, the slider values are both 1 and 1. Now, what's nice here is that we have the answers in front of us, so we can type in those slider values. So the first answer would be if a was -2. So I'm going to just type -2 and press enter. And then b is +2. And remember what we're trying to do
Yeah.
here. We want exactly 2 real solutions. Well, this is
This is
a
none.
different problem. This would be no solution, right? Okay,
That's
so
wild.
next choice, it looks like a is -2 and b is 4. So I'm just going to stay on the b parameter and type 4. And notice just at the bottom there, it's showing you what it's assigning to that parameter. So b is 4. And turns out that's
Hey,
the correct answer, right?
there
That's
it
the one that
is.
has 2 intersections, so 2 real
And
solutions.
then
You know, it's
so
because
I kind of want to point out we're like leveraging this app to kind of figure out the solution to this SAT question. But like Scott said at the start, we're really focusing on math practices, right? What's the math teaching and learning math? And I love using this transform app when I'm trying to like, graph quadratics. What makes it go up? What makes it go down? Left, right, all these things. And what's great is that these kids can do this at their seats playing around and they actually discover what these pieces are doing. So that's like the
different
bigger
parameters.
picture.
So even, bigger than just for the SAT, but this becomes a good teaching tool for you in your classes as well. With, in this case, learning transformations, reflections, translations,
Yeah.
that sort of thing. Okay.
This
All right.
would be a rough one to solve without. That's for darn sure. That would be
You'd
a
really have to think through it, right? You'd really have to think through it a lot and you'd have to have pretty good command of transformations. Let's take a look at the Inspire side. Kind of similar. It's not, again, not an app. It's just kind of a built-in feature. So I'm going to come to my TI-Nspire here. And let's see. I'm going to go to my graphing window and I'll type in the horizontal line. And we see that on the screen, y equals 3. And then I'm going to type in a. And now it's really important that we use the operations. If I typed in a and then x, it's going to think the variable is called x. And the 84 doesn't do that, but the Inspire is very operation entry based. So a times x squared. That's a common mistake that students will make, just to point that out. Let's see. I was not done entering that. So plus and then b. And what's really neat here is that because a and b aren't part of the relationship between x and y, it automatically gives me the option to add sliders for those. I don't have to go to the menu and insert a slider. It will create them for me. Okay, and then when they're activated here, I can move them around so that they're away from what I'm looking at graphically. You can move the sliders manually, like I'm doing right now. But in this case, I probably would go in and type in the values I want, kind of like we did on the 84. So A was -2 and B was +2. And we saw that that was the no solution. And then I might, because A stayed the same, just change the B slider and see here that that is the correct answer, B, where A was -2 and B was 4.
Right. Great tool to
Right.
see stuff. And I think I might point out the question that we have people doing on their own, little challenging. There's some window stuff going on there too. So it'll be a good one for people to try on their own.
Yeah. How about a little bonus here, a little tip just for teaching in general? Are those okay tonight, Pat?
Absolutely. I think the more we can do, the better.
Yeah, I use this a lot when I'm using the teacher software, but if you right click on the graph or control menu and go to attributes. So right clicking on the computer screen, your computer is the same as control menu on a handheld. And if I go down to attributes and I go down to the variable, which is the parameters, if I press to the right, look at what happened there. You can see it just to the right of where that A equals is changing. Notice that it fills those parameters in. And I think that's really powerful because now as I update those parameters, notice that those numbers are changing as the function changes. And I think that's something I use a lot in my classroom. So I think it's just worth pointing out here while we're on the slider screen.
Great. I mean, to coin an old term we used to use was what? Action consequence, right? Doing an
Yeah.
action, we're watching what actually happens. The kids are actually experiencing the math and not graphing like, 100 different problems to see what's going on.
Yeah, you
We
can
can
take
kind of quickly see.
quick look at a lot of different things.
All right. Well, I think
All
our
right.
next one we're doing is a favorite, circles, right? It seems like the SAT, they love their circles to do.
In the last 5 years, it seems like there's been a lot more of circles brought in, which can be a little tricky because where do we cover those in our courses, right? Sometimes in geometry, sometimes it shows up in an algebra 2, depending on where you might have the conics in, right? And if we look at this particular problem, this is pretty challenging, right? Because students are going to have to do what? I'm just thinking my students wouldn't want to do this, but completing the square.
Oh, we just did that in class last week. And any of my students at home, our test is tomorrow. Get ready.
Yeah. And they probably weren't happy to be doing it, right? Especially when we have those linear coefficients being odd. And I'm seeing that too. So this is kind of one of those nasty problems that a lot of students, even if they knew the math, might struggle their way through, especially to be efficient and accurate. Okay, so let's talk about how we can do that on the two different platforms. So on the 84, again, we've looked at a few different apps tonight. We're going to use the Conics app, and then there's a special feature that will get us to the radius that we'll talk about when we get to that point. So let me pull up my 84, and let's see. I've got to quit out of there. I'm going to go to apps and Conics number 4, just right there. And we're working with a circle here. So I'm going to select circle. And we've got two different options. One is this, what are the different forms called? One's called you just taught this, the standard
I think
form.
that'd be like a traditional form. Our textbook calls it weird stuff, but I would just say that's our center. It's displaying our center. It's not vertex mode, but it's like the center of the circle mode. But standard form is like that number 2, right? That fully expanded, crazy, the one it's like we have in our SAT question.
Yeah, exactly. So I'm going to grab that. And it wants to know the different coefficients. Now notice when we enter here, the quadratic coefficients have to be the same if this is truly a circle. So I don't have to enter those as different entries. They're both what they're calling A here. So I'm going to hit A to be 1. B is the coefficient, the linear coefficient on X, which is 1. C is the linear coefficient on Y, which is 1. Now we got to be careful here. The way they've set it up, the right side is equal to 0. So that constant or that number we see on the right, 199 over 2, on the left side would be negative 199 over 2.
Right.
Now I'm going to press graph, but that's not what we're really going to want to do, right?
Yeah.
If I press graph, I'll see the graph of the circle.
Great.
But I don't know that defines the radius for us because it sure looks like it's in between some of those tick marks.
It does.
Right? Okay, so how can I get back there? Well, I think I have to go back to the app.
Right.
I gotta go back.
Happens to people, right? They press graph by mistake. It's a natural thing.
I got to go back in. Lucky for us, it's already there, so I don't have to redo it. But from this screen, the key quick way to find both the center and the radius is if we press alpha and then enter, which gives us solve. Alpha enter will give us the center and the radius.
Now, what I like this, when we were doing some work in class, Scott, we did a couple conic sections, test tomorrow again. I would have the students calculate it on paper, right? And then we would use the app to like, okay, let's see if you're right. Let's check it out and see. It was a great tool for them to learn how to use this quickly on the SAT, but also to use it to check their work, see if they're correct or not.
Yeah, absolutely. Okay. All right. So let's see what this looks like on the Inspire side. So we're going to graph this using the conic template. We could also graph it as a relation. And then we're going to use analyze conics to find the radius that we're looking for. So let me pull up the Inspire. Let's see. Let's clear out my scratch pad.
Right.
And I'm going to go into menu because I need to enter something a little bit different. So my graph entry, I want to enter it in as a conic section, and those can be found in the equation templates. So this is kind of like the 84 app in a sense. I just have to access it. And there's different ones, like for a line, I could enter it in the different forms of a line. For parabola, you've got the different form. I mean, there's 4 different ones here depending on if your parabola is opening up, down, right, left. And then circle, again, I have the center form. I guess that's what it's called.
There you
and
go.
Then the standard form. Okay. And so we want the standard form. And again, it looks a little similar, although we get to type them in kind of as we go. This is kind of neat that whatever you put in as the quadratic coefficient, they automatically put in as the other quadratic coefficient. So, because they have to be the same. So we only have to enter it once. And then the next 2 are ones. And then let's see, I'm going to do control divides to get my fraction template, -199 over 2.
Perfect.
Okay. And I'm going to press enter to graph it. Now,
Wow.
we could resize the window in order to see the full graph, but because we can see the circle somewhere, we can use the tool that will find the radius length. And if we go into the menu here and I'm analyzing the graph, we have all those nice tools that we talked about earlier that show up on the 84 as well. And then at the bottom, we have analyze conics. And so we have a variety of tools that we can use depending on the conic section. And I want to find the radius here. And so if I grab that tool and if I just go arrow over to the circle somewhere, we can see that it's drawing the radius and telling me, and if I press enter, it will actually drop. Well, I have to press enter twice. It will drop that radius value down. So the answer to the problem is 10.
Man, how great is that? It shows the visual radius 10. There it's drawn. That's beautiful.
Yeah, it's really nice that it does that. Okay. All right. How much more do we got, Pat? We got about
a
more minutes.
Yeah, I think we might get there, Scott. I think we might get there. Our next one is graphing inequalities, right? So again, here's your question to do at home, but here's a good old, system of inequalities. We want to figure out which point works in both. Yes, there's lots of ways to do this, but we want to focus on that kid that gets stuck, right? So the 84 has a really great app called Inequals, which helps people graph a system of inequalities and does lots of great stuff. And then once we graph it, we're going to use our arrow keys to move to the different solutions that they have there and figure out, gosh, which one is correct? Which one is in that overlap? So let's get rolling. Let's go ahead and graph this using that app.
No, I feel like this is an apps workshop tonight. We've been doing a lot of apps on the 84. Okay, so let's quit out of that Conics app. And in apps, number 7 here is Inequals.
Right.
And we could you could actually do this without the Inequals app, but let me just show real quick. If we go to y equals right now, to the left there, I can change. Well, I got to shut down the transform app, don't I?
Right. Yeah, that's what happens when we're running a lot of apps. We got to remember to quit them out.
Yeah, so I didn't quit that out earlier. So transform, I got to quit that app out. But anyway, y equals now, you could always go to the left and change this. The line could be shading above, shading below, that sort of thing. But I like the Inequals app even better. So let's go ahead and activate that so that we can see how it's a little bit different and that it's helpful.
Right. And what's nice about the Inequals is student that doesn't need to remember that, oh, this is shading above, this is shading below. They actually pick the symbol that it is, which is great.
So now that the app is on, if I press, sorry.
You're good. There you go.
Yes. So if I go to the left,
go
to the same place, right now it's showing it as an equation. I can change it to the correct inequality symbol. So it looked like it was less than or equal to, so that would be just a couple over.
And notice it
And
changes the style for you. Hey, that's shading below.
yeah, that's
Nice.
kind of nice. And it gives the right symbol there, which is neat. And let's see, I'm going to type in the x plus 7. And then for the next one, let's clear that out from our work before. This one I want greater than or equal to. Okay, and then I want negative 2x minus 1.
Right.
Now, glance down at our answers here. Is the standard window going to be the best option for us?
Hey, I think you did a negative instead of a
Yes,
minus.
I see
You
that.
know, this happens to all. It happened to me today in class. I couldn't figure out what was going on.
There we go.
All
Okay,
right.
so if we glance down our answers, our standard window would get us negative 10 to 10. We got to go negative 14. So I would probably go into my window, get
Right.
that set up right away. So negative 15 to 15 and negative 15 to 15.
Right.
And now if I press graph, and remember, we're looking for where those overlap. And
Right.
so this is kind of nice if we look at the answers because we could use our arrows here to just kind
Right.
of work around. But I think we see that if we go too far left, we're outside of both regions. Go too far down, too far up, it's the one where we're moving to the right. So 14 comma 0 is our solution there.
It's definitely in there. Right.
Okay.
Nice visual for the kids that are really like hung up, like, man, I don't know what to do, sir. I am really messed up on this. Well, now you've got access to maybe get that question right now. It's a
Yeah.
pretty great deal.
Okay. And then on the Inspire, we're going to graph relations here. So let's show that because that's a neat feature on the Inspire. Let me pull that up. I'm going to clear my scratch pad out.
That is such a
And
great tool using the scratch pad, Scott. I got to say, that's a game changer for me. That's really great.
I just think it saves you a little bit of time and you just keep going back and clearing it out and starting over.
Right.
So I'm on the graphing side, and now this is really neat that it's set up to enter in functions, in equation form. But if we hit delete and go back, notice here, I'll do that again.
Ah,
If I hit delete and go backwards, it has the ability to jump in and set up kind of the inequality statements that we
mhm,
want, which are relations because they're not functions typically, right? Depending
right.
on, if it's a horizontal line, it could be a function if it has an inequality, but these are not. So y is less than or equal to x plus 7, and it graphs that one. We
Oh,
can
look
see
at
that on the
that.
screen. For the second one, now notice it's in relation form, so I can type that one, which is y. Now, to find the inequalities, you've got to hit Control and equals.
Mhm.
We'll get the inequality symbols. And so y is greater than or equal to negative 2x minus 1. Okay, and now we see both of those. And again, remember our window, the standard window on the Inspire is not negative 10 to 10 and negative 10 to 10. It's negative 10 to 10 for x and negative 6.7 to 6.7 for y. So I'm going to go ahead and change this around. I want to see, negative 15. Now here's something cool. I changed the x min. If I press tab on my Inspire, it goes to the next one in a clockwise order. So notice it went up to my y max. And if I press 15, I can tab to my x max, type in 15, tab to my y min, negative 15. And
That's
just
nice. That's a quick way to get that. And you could go to window and do it too, but it's so nice seeing it on that graph and just
yeah,
tabbing
I like
along.
that you don't have to leave the screen because sometimes students don't kind of connect to what does X min mean? What does X max mean? And so they don't have to leave the screen and they can just physically change what's needed. You can also change, just a heads up, you can change the scaling value. So if I didn't want to go by ones, but maybe by fives, those can also be changed,
Mhm.
which is kind of nice too. Let's see, it's hard to, sometimes when there's two things there, it's a little bit hard to get them. But again, we see here that they overlap to the right side. And so we have 14 comma 0. I could even, plot a point by coordinates here and say 14, enter 0. And we see that that point
Ah,
is
there
in the
you go.
solution region.
Nice.
Okay, so that's an extra little bonus as well.
That
Okay,
is great.
so where are we at for time? Do you think we got time for one more?
Well, I think we can start until Mike kicks us off. He's the one running the show, so
I just saw a
let's
yes in the
see.
chat window, so he's good with it.
Okay, all right.
Oh,
So our
we just had
last
a
one.
question.
Yeah.
I want to review that. Yeah, plotting a coordinate.
Oh,
Yeah,
here we
please
go.
ask those types of questions. If you just type, the quickest way is if you just press P on your handheld, you get two options. And if you want to plot a point by coordinates, you can type or hit enter on that, and then you're just typing in the X and the Y value. So if I wanted to, for example, plot a point at -10, hit enter, and 0, enter, it will plot a point over there. So
Oh,
that's kind
perfect.
of a nice feature.
So no parentheses. You're just typing in the X value, enter, Y value, enter. That's it.
Yeah, it's set up as a template for you. Okay.
That's awesome.
Yeah. Okay, so let's see. Last but not
We
least,
have it. Now, some of these, so graphing equivalent expressions, right? So, I mean, yeah, we're all math teachers. We get this, distribute the negative, combine like terms. Sometimes they're really crazy, bizarre problems that you're trying to simplify, right? Because kids are so good at algebraic simplification. But what we can do is this. Our idea is this. You graph the problem, right? So we'll graph the problem, and then we start graphing the different answers and see when one graph's on top of the other. Now, a really nice feature that some people may not be aware of, right? The calculator, it tends to graph things very quickly, which is what we want it to do, right? But sometimes it's hard to see if it's graphing it on top of the other. So there's a way to make it do a path plot, and I think they call it, yeah, it's a path plot. It slows down the graphing. So
yeah,
let's do this on the 84. We're going to go ahead
yeah,
and type in the expression that they gave us
yeah. And
exactly as it appears.
and just to say with what Pat was saying, you know, there's sometimes some really crazy expressions that students are supposed to work with, right? I've seen even something, I'm putting down the app here. I've seen like some rational expressions where
Oh,
the
yeah.
simplified version is really found out by doing long division and has a remainder. And, you know, it's really difficult algebra that some students aren't going to be able to do quickly or effectively or efficiently. So we're going to type in here the first expression.
Right. And this will be the blue graph. So the blue graph will be the problem, right? We're trying to get something to match the blue graph. And then Scott's going to type in, let's just try part A, right? On the red graph for Y2. So the idea is that if the calculator is graphing really slow, we would be able to see that blue line slowly become a red line because the red one's on top of it. But the deal is it graphs that red one so fast. So Scott had done this earlier by arrowing all the way to the left. And when we press enter, oh yeah, let's fix this. If you go to
Yeah, I got it.
line, gotcha. We can hit up, using the arrows. We have two extra options. That one there, this one is a circle with a line after it. And what that's going to do is it's going to make a like where the pencil is as it graphs the graph, right? As
Yeah,
it
so
graphs
it
the
gives a
equation.
little bit of the path as it's graphing it.
Yeah.
It slows it down just a little bit. We know they're paying attention, Pat, if they're
I
catching
know.
our
This is
mistakes.
great. Thank you so much, guys. It warms
Okay,
this teacher's heart, people checking
all
stuff.
right. So yeah, so if I hit graph, we see that first
Oh,
one,
that
and
blue one. Did you see that red one go by? Let's hit,
it goes so darn fast, doesn't
it
it?
is.
Oh, I hit enter, that's why.
Oh yeah, it's paused up. Right. There we go.
Yeah, it's like it's paused up. So let's see. I don't know if I can do it again without kind of clearing this out. One thing you can do, and I tried to do that there, was you can hit enter on the handheld and it will pause the graphing.
Okay, so let's slow down a bit. Scott's going to press enter in a second. Let's all watch carefully. Watch this red graph go whizzing by. But that slow path, there it goes. So you can see it.
And I've been pressing enter a couple. You can see that it goes over the top of it.
Uh,
Okay. Now we got lucky that it was the first choice, right?
Right.
Because this could be a little tedious to enter. It might be one where you
Sure
save it
could.
for the end of the test, so to speak.
Right.
Okay.
But that slow plot is great when you're trying to illustrate a graph for kids as you're graphing stuff. Let's really see this path come out
Yeah.
really well.
And you can do something similar on the Inspire as well. Do we have time to show it, or should we kind of just?
Mike just came on. I think he's shaking his head.
Okay.
I don't think so.
Yeah. So a similar feature on the Inspire as well, where you can actually do a path plot with the trace menu in there. And I think we have maybe a little bit, more for you to look at for the screenshots for the extra example.
So work
Okay.
these out at home, everybody. Practice this stuff. It's great techniques for your kids.
Thanks, guys. I do want to wrap things up tonight. First, I want to give away our TI graphing calculator tonight, and tonight's lucky winner is Wanda Fulmore. So, Wanda, congrats. I'll be reaching out to you soon over email to get some information. To receive a certificate of attendance, click the link in the chat window. Also listed is a link for the documents that Pat and Scott used tonight. And if you're watching this on demand, copy that link into your favorite browser to receive your certificate. And finally, huge thanks to Pat and Scott for everything they put together tonight. I love all the extra screenshots for both the 84 and the Inspire. I think this will be great to be viewed like on demand later, so you can go at your own pace. You can try some of those extra problems. I love there's like bonus problems that people can try as well. So thanks so much for all the extra time you put together with all the activities for tonight.
Great. It was fun.
You're welcome. Yeah.
And thanks again to everyone for joining us tonight. This wouldn't be possible without you. So thanks for taking some time with us tonight. We appreciate it. We hope to see you back online next week. Have a great night.
Good night, everybody.
See you later. Bye-bye.